If we've got these values, all right, our cyclist accelerates from rest to a velocity of 10 meters per second in 12 seconds with constant acceleration. The first question is asking us, what is the acceleration? Okay, so first things first, we are going to try to find AX. And the reason I put it in the X is because pretty soon we're going to be doing free fall, and that is motion in the Y. So I'm going to start to differentiate between the two now. Okay, so if this is the actual given that we're looking for, we need to look at those 4 equations and see which one we can use. If we look at our 4 equations, if we're looking for acceleration, first things first, we have to cancel out any equation that does not have acceleration in it, and that is equation 2. All right? Next, we've got to look at, are there any other variables that are in these equations that we don't have? And if we look at our list, we don't have either of our displacements. So that cancels out equation 3 and 4. Okay? Equation 1, all right, so I'm just going to mark a little 1 up here, is V final is equal to V initial plus A delta T. Now, you stated that why don't we just use A is equal to delta V over delta T. Well, that's exactly what we're doing. That's exactly the equation we're using. Okay? Now, if we look at this equation, so first things first, you must write out the givens. We did this. Next, okay, so actually I'm going to put a number 1 here. Number 2 here, you must write out the equation you are using. You must show me which equation you are using. Okay? Now, once you've written out your equation, you can rearrange the equation or you can plug your numbers in. Some of you like to just plug numbers in right away and then rearrange. I don't care. Okay? But I need to see your work. And you must include units. You must. All the way through. You cannot just have a bunch of numbers and then plop in a unit at the end. You will lose marks. Okay? So, how do we rearrange this? First of all, can we cancel anything out here? What gets crossed off here? V initial is 0. You're starting at rest. Get it out of there. Okay, well, we're leaving it at delta T because it's just going to be T final. Okay? So if I want to rearrange this equation, if I rewrite this, I end up with V final is equal to A delta T. If I want to solve for A, I isolate the A. And look at that. You're left with this original equation rearranged. So that is what you used. Okay, so in this case, A is going to be equal to your V final over your T final. Now, what is V final? 10. What is T final? Okay, so I would put this in here. 10 meters per second divided by 12 seconds. And in this case, wow, look at that. It ends up with the right units. Meters per second over seconds is the same thing as meters per second times seconds to the negative 1. So it gives you seconds squared. Okay, that is the unit for acceleration. So if you want to work this out, it ends up being 0.83. So A is equal to 0.83 meters per second squared. So that's part A. Now, the second question is asking us to find the displacement. So with that acceleration, we can move on to the next part of this question, which was, what was the total displacement of the cyclist if he's traveling at 10 meters per second for a duration of 12 seconds. So now that we have our acceleration of 0.83 meters per second squared, we can now plug that in. That becomes one of our usable variables along with everything else in our list. So think about which of the formulas you would use in order to calculate final displacement, or XF. You've got a few options. In reality, you could, my suggestion would be to use either formula 3 or equation 3 or equation 4. I'm going to write out the equations and then we can kind of look. You should, in theory, come up with the same answer using either of these equations. So really this just becomes a familiarity thing, where if you're more comfortable using equation number 3, then by all means. We know that if we use equation 3, the VIT, this section right here, ends up canceling out because we start at rest. So that eliminates that chunk of variables. We also know that this is 0. So really we're left, if we use the first formula, with this section of equation, whereas, we're left with a similar set if we actually use the fourth equation, because VI also cancels out. So let's try and solve this using both formulas, just to see if we get the right number. So here on this side we'll do equation 3. So X final is equal to 1/2 a t squared. And now let's plug in the numbers and let's see what we come up with, because we don't have any rearranging to do. So if I look at this and I've put in all my units, this is actually going to work out because the units for acceleration are meters per second squared, and if I'm squaring my time, I'm going to end up with seconds squared. And these guys are going to end up canceling one another out, which is going to leave me with the unit I'm looking for. So by punching all this in, I end up with 59.76 meters, and if I round that, I get about 60 meters. So we're going to see if we do it the other way using equation 4, do we get the same answer? So here's equation 4. Now this one is going to involve a little bit of, reworking. So we're going to pause it and rearrange this, and then we'll put the numbers in. So we see that if we actually rearrange this equation, X final in this case is going to be the V final squared divided by 2 acceleration in the X. So let's work this out. I've input my numbers, and let's see if we come up with the same answer. Doing it this way, my answer comes up to 60.24, also rounded to 60 meters. So either way, you're still going to get the right answer. You don't have to do more than one equation, but this is just to show you that you can choose more than one path to get you to your correct final destination.